Hello, my name is David. I'm a software developer, and I'm making a series of videos just to kind of example some of the work that I've done over open source projects. And one of the projects that I work on is a client that I had made called Parthia. It connects up to an old text game called The Eternal City. And with this, what I'm going to be covering today is a mapping system that I had developed that tracks the character's location throughout the game. If you haven't already watched it, I did make a video on actually how I turn text only that I received from this game into this map um, here to the right. And the way I'm going to cover briefly how I've done that, I do recommend watching that video, but to get a kind of a better understanding. But I'm going to, you know what, the window's already open. I am going to actually cover briefly how that is done. The way that I wind up doing that is as I walk, I wind up receiving these these text messages. So one thing I would point out is this unfiltered line message is what I wind up receiving directly from the server. I never actually receive any kind of information. There's no data stream that provides me pictures of this, nothing along that lines. I'm just getting this text from the server, and text is the only thing I ever get from the server. So in this case, what I've done is I've taken this line here, and I've determined that there's a pattern to tell me where these rooms are in this map. And the way I wound up just so I discovered it just by reading it. Actually, I didn't have any information, but what the pattern actually is that first it's the X and the Y position, the size of the room, the color of the room, how much light is in the room. And then you'll notice here that the pattern just simply repeats. So I've set up a regex um, that will go through and it will loop through all these every time it sees a new room. It records that position of the room, and then it tells it that this label should be here. And then it goes to the next room, and this label should be here. It's that size, so it resizes the label, makes it visible, and then the similar thing happens down here that you'll see that these are the information that I need for the exits of these rooms. These exits are just these little dashes that you'll see here. And with the exits, if I'm remembering correctly, it's the X position, the Y position. If it is vertical or horizontal, there's actually also diagonal exits as well. They're labeled NE for northeast and NW for northwest. But then you'll wind up seeing that that it just winds up just as with the rooms, the patterns just go through and they repeat themselves. Oh, and then also there's a if the exit's open and closed there as well. So it lets us know if it's a door and that it's closed or maybe it's locked. So at least have that much information from it. So now we have a very vague idea. I'll go through and explain what I've done with the map and the map that allows you to track yourself. So I'm going to actually add in the window that lets us see that map. Lists, map, and I'm going to put it over here because I want to see both the maps at the same time. And then I'm going to enable the mapping system, Parthia map, and then I'm going to enable it and start mapping. And then we'll see here if when I move, does it actually go through and do all the mapping that I want it to. All right, which it does. And what I'm going to go through and point out here is that I'm only receiving text. And also, most text games, when you have a mapping system like this one, like a more complex one here, that's going to go through and track where you are, typically you'd either be given your coordinates of the room you're in the world, your X and Y XYZ coordinates, um, or a lot of the times what they would wind up doing is they would send you the data of your entire area. And that's kind of what's been provided here, but there's no information provided other than just how to draw these rooms. Um, I had decided that I wanted a project where I would make it so you could track where the character was moving throughout this world. And the way that this winds up occurring is when I receive the text, it gives me the positions of this room. The red room is the room that you're currently in, which is important. And the position, the XY, is the top left corner of that room. And that's the case with all of them. So all these rooms, their XYs that we receive is intended for the top left position of that room. And then it tells you the size. So it lets you know how big that room needs to be drawn. So what I have wound up doing um, is if the only thing that you were doing was traveling in a direction and changing basically changing a room, all you would need to do is track the size of the room that you were previously in, comparative the room that you wind up going to, and the direction that you're going in, and that would wind up allowing you to get the data that you need to at least find the XY position of the room you need, the new room you've gone into, and you need to draw the position of. There was a large number of technical challenges that prevented that more simplified method. One of them is you can see here how there's two rooms off these smaller rooms because the direction that you're moving in is a fairly important part of of the entire equation because there's no way for you to actually know what direction you're in by by the text that you just simply wind up receiving in those messages with the numbers on them. So what I wound up doing is, so for every single time that you enter a room, the room that you're currently in, I track all of the rooms that are adjacent to it, and I record the rooms that are next door to it. And then I go through each and every exit and I find what adjacent room is connected to it. And then once I've collected all of those, I keep that data for that room when I move. I keep it for just a singular step. That's all I need it for, is I just need it for a singular step. And what happens is you'll see here when I go to the east, I go into that room. No matter how many times I type it, I'm going to go into that room. If I type in east, I'm going to go straight into that same room. But if I wind up typing probably go if I type in go arc, I bet you it's probably that same room. Yes, okay. But if I type in, you'll notice here go to arc, I'm going through the second arcway, and I'm going to that room that's just a tiny bit to the north. This is one of the rooms in the hospice. It's where you treat patients in this game. But being able to figure out how to do that wound up being a rather surmountable, frustrating mathematical equation. Because another thing that I had wanted to do as I was processing all of this, I didn't want to do it with straight math because you could actually do some of this just with straight multiplication, maybe perhaps some division. But I definitely used a small amount of multiplication for the room sizes, and then I do use some amount of addition as well. But at large, what I wound up doing is I wind up basically tracking that previous room, and when you move, you need to find when you're going into a brand new room, you need to find the previous room according to the room that you're currently in, so you can accurately draw where you are on the map. Because unfortunately, the direction alone wasn't sufficient. And the way that I wound up being able to do this is referring back to that previous room. And what I do is this exit right there, because previously, and I'm just tracking it in an array. Technically, it would if you were this is all done in Lua, so it's called a table. But if you're a Python programmer, it would be a dictionary. If you're a PowerShell programmer, it would be I believe it's a hash table. I like to just call them the JSON data types because they look just like a JSON when you go through and make them manually. But what I'm doing is I'm tracking this exit. I'm tracking what room is on the other side. That's why those adjacent rooms were important, because I'm tracking what room's on this other side. And the reason why I'm doing that is because when I move, the direction wasn't sufficient to find my position. So what I wind up doing is I go back to the previous room and I find this exit, and I wind up I wind up using that literal exit to track where I've gone. This wound up being really, really difficult um, because you have to find out the information about that exact exit. And you'll notice here as you walk, you'll receive this message that you walk through. So it's giving me the name of the exit that I've walked through. That's some of the information that I had needed. And then you'll also notice that you arrive at a small room you are facing, and the direction was really important because sometimes, for example, another technical challenge was the character doesn't move themselves. So sometimes you have to be able to track the movement that is forced onto them. So these are some of the technical challenges that I basically overcame in this case by doing a bunch of pattern detections to be able to find out where I'm going. Now, the reason why I didn't want to use math is because I'm referring back to these tables to get the X and Y positions to help me adjust and draw everything um, to where everything needs to be drawn here on the map that's on the left hand side. That was important for me because for one, um, the character can do one command a second in this game, so I have 1 second to be able to draw and do everything that needs to be done. There's plenty of processing time for that in all reality. For me, it was really just more of a fun technical challenge to remove as much math as possible and refer back then and to an entry in array. Um, because this does not get exposed to application users often, or even for that much to software developers, how inefficient computers are at doing math. They're very very good at it, but they're in general they are not efficient at doing math equations if you're using the standard symbols. So what I wound up finding is when I was using math, it was taking about 300 to sometimes up to 600 milliseconds to be able to go through and do all these equations. I won't get in depth on it because, for example, at that time I was also doing things like I wasn't weeding out the adjacent ROMs, so there was a lot of needless math that was occurring at that time as well. But what I wound up doing is I was able to take that 3 to 600 millisecond time frame, and it's down to pretty much about 30 to 60 milliseconds every single time somebody enters a room. It goes through and does these calculations very rapidly in comparison to what it would have done had it been using actual math. That's just an example of how using a data array is considerably faster than using mathematical equations. If you can use a data array in place of mathematical equations, use the data array. Even if you're pre-making a data array, you're putting information in it beforehand, and you're caching it, setting it aside, and you can refer back to that because it's a lot less processor intensive to go back to a memory registry than to calculate an equation. That's what it winds up boiling down to as to why I've chosen to do that. Now, what I'm going to wind up doing is I'm gonna pause this video, and I'm going to wind up pointing out some of the technical challenges that I had when I was making this math system or mapping system. Uh, and I'm just going to kind of pause it to go through, find the troublesome spots, and explain how I had overcome that programmatically. All right, we can see here. Here's one that was extraordinarily easy to resolve, but it's a problem nonetheless. You'll see how this exit goes to both these rooms. It does not actually. It goes to this room that's to the left. Um, just by using just by probably even just going and doing it enough times because this is a common area. If you travel in this direction, so from this room to that room, the mapping system records also. Don't That's one thing to mention. The mapping system records these positions as you're moving along. So when I go back now, if I were to start here and go up, the mapping system would not be able to detect that. It can't determine that this belongs to this room or this room. It doesn't know which of them. But since I've already connected these two rooms, mapping system says that these two rooms are already connected, and I can now traverse between the two automatically. So that's been done. Basically, that gets solved with the way I wound up having the map system do do path finding or path choices or link choices after the linking has already occurred. So just one item, wanted to be able to cover that. All right, and then what I've done here, I've gone into an area of this game that has some steps, and what's important about that is that steps will mean that you're moving on the z-axis at the same time you're moving on the x or y. And another item you'll notice if you look at the standard tech map, I'm going to an area where the next room is not visible, so that winds up meaning that the way that we typically would guess or not guess or actually know where that next room is located, we can't know. So basically, what we wind up having to do is we actually have to guess the way that occurs, and the way that I wind up doing this is I just do it off the size of the room. So that way when you move, I don't remember the equation offhand, but I believe it has to do with like half the size of the room adjusted by the XY position that you're moving in. So you'll notice here that if we look at our map, we have a skeleton of this map here. And in fact, so much so to the point that, see, if this room would wind up being a match for that room, then there, and then there's the big room there. So we even have items that are drawn off the screen or off of this screen. So what's going to happen here is when I go west, I'm actually going up some steps. Part of this here is important because this message is saying that we've climbed some steps. When that occurs, you're not going to see it now because it's already been mapped. But when that winds up occurring, you'll wind up seeing um, the person mapping it will wind up seeing. And again, I'm going to briefly mention that this system's been designed so a person initially does the mapping, and then it's distributed for other people to be able to use so that they don't have to go through any of the new mapping processes. This would be an example of a new mapping process because when somebody walks up the steps, they wind up seeing this message, and basically this message is just saying that we've seen some steps, that you've moved on steps, and we don't know if you're going up on the z-axis or if you're going down on the z-axis. So you actually have to. That is one item that you do have to tell it. There's no dynamic way to be able to detect that on your own because, again, unfortunately, we're not getting room coordinates, and we're definitely not getting um, z coordinates movement easily. So when we move up, like maybe if you climb up a ladder or down a ladder, if you like use the up command, you can use that to know you're moving up on the z-axis. But here we're moving in a direction, east or west, and there's no way to be able to detect where we're moving on the z-scale. So one other thing that I wanted to point out here is here on our mapping system, you can see that I have just these are bleachers in a coliseum. So I have just this row of these bleachers, and when I wind up moving over to the steps and I go, and I go back down again, you'll see that we've gone back down those steps successfully. And when I did that, when I originally mapped that, I had to tell it that steps are going to go in the downward direction. So with that, I'm going to move on to the next challenge that I had run into. All right, and then now moving on to the next technical challenge with this project. And here, I'm just going to point out a neat item of the game. I didn't turn mapping off when I was in the Coliseum. I just left the game's Coliseum. And I had my character walk to the nearest grassland. And the reason why I wound up choosing to go to the nearest grassland is because it was an example of our next technical challenge. When a character moves in this game, they can use the word of a direction like east, west. They can use the first letter of that direction, E for east, W for west, and for north, so on and so forth. They can actually even use numbers. So one of the items that I've done also is I've captured all the methods in a very complicated regex pattern to be able to detect all the movement methods, standard movement methods. So another item that's going to, however, wind up occurring is going to be when somebody winds up wanting to move according to the name of a direction. So I'm going to wind up going here, and I'm gonna type go grass. So now when a character makes a movement, we do not actually necessarily know where they are going to be moving based off of the character's input. So I can't just say like I'm going to press enter here so I can find out the direction. Okay, I can't just simply say that the character from based off of their input that they're going north. I could collect it from this message, but I do not believe that that message is always going to be available. So what I wind up doing, so if I go and then I'm gonna go back to the south, and what you'll notice is as I am moving, um, you'll see here that it is in fact, even though I'm using this, I call it the special exit name. Even though I'm using the special exit name, it's going through go to grass. It is every time having me go in the correct direction. It's having me go north when I should be going north. It's having me go south when I should be going south. Goes three grass, um, and going to the east, and then let's go four grass. I think that makes me go to the west. Okay, and that's just this one being kind of a good example because you can see here I'm at the end of the grasslands. Now, what I had wound up doing with this is the only way this works is if it's been pre-mapped by a directional movement like east west or using some of the numbers. And what I wind up doing is as you leave a room, I record the special exit name that you walked through, and I'm recording the way that you wind up getting into a room. So what you would need to type to enter that room, or as you're leaving a room, what you would need to type to exit that room. And what I wind up doing is I link that the any of the forms, by the way, of that you could type that exit name because I'm actually doing a shorthand when I type go for grass. I'm actually doing a shorthand go grassland. So I'm recording first the full grassland, and then I'm actually then from there using a regex pattern to then further if you're typing in some go then a message, I'm then further using a regex pattern to be able to find the proper pattern of a special exit name that you're using. And that's all all of that is what is needed so that when somebody types in go and then a special exit name, all that is needed to properly map the exact proper coordinates that they're moving in. One item I would wind up pointing out is again, I've got a grass snake attacking my character. As I would wind up pointing out that none of this was pre-provided for me. All of this I had to just determine on my own, and it is equations that I just basically developed all of myself. So I'm gonna move on then, pause here, and go on to a few other technical challenges. All right, another one of the technical challenges is that you can use multiple characters. In this game, and actually most text games, you can use multiple characters. So what that winds up meaning is that they are going to change, um, maybe not just maybe not just you map, but an area on a map, but they might even just change to a completely different map entirely. So I'm just going to example that here is when I exit from this character, I'm going to go into the welcome area. I've already pre-mapped out the welcome area. And you can see here, the system automatically detects that you've logged out. You're no longer in your as your character, and then it was going to actually automatically swap the map out to the proper map and also location for that character because it's going to wind up recording the location where that character last was when they wound up exiting the game. So the way I wind up doing this, as you can see here, that last message that appeared on the screen says, "Please wait while we collect information." Well, what I wound up doing is at startup, I wind up in the background. I run this command, and then I collect all the information that's on this command. While some of it is like not pertinent, I still collected all of it. The only thing I actually care about is that right there. It's going to be the name of your character. It's going to be unique to your character and that character specifically. It doesn't matter how many characters that you have; they all have to have a unique name in this game. Even among characters whose players don't have a specific account. Every character name is unique. So I wound up using them to say when you switch characters, you record the information for that character, the position on the map itself, and then when you swap characters out, it'll move the character to it'll move the map to that character's position, and then show the active position where they belong. This even works with if I log into the welcome area. If I were to then, I don't have access to any of my other accounts right now, characters, but if I were to log in as another character who's back in the game, but different than my primary character, then it would wind up putting me in that character's proper position within the game map. So that is what I wanted to cover for this technical challenge. All right, so on to the next technical challenge that we ran into, and then I'm just going to point out. I'm just seeing how much mapping data I can get before some kind of error occurs. But we can see here, there's that grasslands. Here's that Coliseum that we were in. Now I'm at the library. It looks like I've trekked around. I did at the library. You can't enter it with weapons. I had a character had a big old stash of weapons, so he went up to the market, and he went to the bronze cellar. There's where the bronze cellar shop is right there. Sold it, and then walked on back down to the library again. So the library, there we are. Okay, and then so the library has um, what I wanted to use as the next example. All right, so now um, I'm going to go to something you see here. We don't. I'm going to go type in go desk. Um, there's a couple of things in this game that are kind of frustrating in this way. But the desk is basically a directional movement in here that's available, but it doesn't appear anywhere on the screen at all, except for just to say that there's a desk. So I'm going to type go desk, and you can see now I've actually moved to a different room. You can tell it by here. We're in a room with no exits, and that's actually important because if we had this type of movement and we had some exits, that the mapping system would want to wind up linking these. But since I have no exits at all, there's no exits up, there's no exits down, there's no special exits, there's nothing. Um, we can basically say that we want to stay at our current our previous sorry we want to stay at our previous position. So now I'm gonna leave the desk, and after a few moments, I've now, even though the movement has occurred, I'm still at that previous location. So I'm going to make certain that I can leave the library, and that I can continue to track my movements. The guards patting my character down. I can leave the library without any kind of mapping issues. Guards patting me down on the way back in again. And you can see there, even though I'm moving into a room, no exits, and those exits were important for the mapping. It lets us know, since there's no exits at all, we want to keep our position. And because, as you can see, it didn't wind up affecting um, movement or tracking, map tracking throughout the game here. All right, sorry for the abrupt change there, but I was going to cover here was terribly briefly some of the coding that's involved with this. If you actually are interested in this and you wind up downloading the code, or you can even just you can play the you can download the client from the wiki page. There's an installation reference there. And if you press Alt and E, or if you just go to edit, you actually be able to see this window. And in the script section, And if you expand that and go to Parthian map, is all the information for the mapper. It actually wound up requiring a rather large amount of code to be able to do all of this. But I was briefly going to just point out the movement that occurs, and this is the primary function that controls movement. There's a lot more involved with it in the background. And I like the finding those special exit names, finding room exits, finding the adjacent rooms, finding the areas of rooms. But I was just going to simply point out it as I go through, like here, I've actually been using this to find some of the technical challenges that I had ran into because I haven't actually worked on this for a year, maybe pushing two that I've actually, what day, 2022? Yeah, it's been like a year to 2 years since I've actually worked on this, so I actually had to review the code myself. But I wanted to point out if I'm going through, I wasn't gonna like go through everything with this, but I was going to simply point out here um, that with this, if like the way I wind up handling movement is movement where we know the location winds up being much more like that's the whole block code for movement when we know the location winds up existing. It's actually not that big um, with all considered, and it actually allows us to do things like those special exits. So when somebody, instead of choosing a direction, types out the name of an exit, allows us to be able to track that way. And this is when we already know where we're moving. Now, if we wind up moving on, we're moving, the character's moving into an unmapped space, is where things wind up getting a little bit more frustrating. And we can see here, this basically just winds up being information about, for like example, making certain we have the data that we need, and if we don't, we set it to initialized, like we basically initialize it. So that's all that that section is there, and then from what we're doing here is we're dir is just the direction that we move. It's already been previously collected for us um, with a different function. One thing I would briefly point out, Lua is really good about having global values. So a lot of the times when I'm writing the Lua function, I'll be lazy and I'll simply refer to the global values. It's not something that I do like in a work environment. It's not something that I do actually even when I'm using Python because technically you can use global variables with Python. I wind up having the code be much more clean there. Just for whatever reason, this superb easy access to global variables kind of makes me lazy when I'm programming specifically within Lua. But that all said, what I wind up having here is I'm basically saying that I'm verifying that I have a previous room, and if I don't, you're basically then reinitialize some different data. But you'll have here, this is kind of what I wanted to point out is I know before I mentioned that I was tracking the room and the exits, and there's the direction that I entered in from. So like let's say I entered in from the exit to the west, um, then it literally this 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 well, I'll call it the JSON or the dictionary data type. I'm saying I want to go into that memory entry for the direction, and then it's entry index for that direction because you can have. Don't forget, we can if we let's say if we're referring back to the west, we could have two western exits there. So we've actually also done some additional calculation to make certain we're using the correct exit. So I'm actually just verifying that there was room data there. And then from there, I'm basically saying there's the half the room size, and that's what we really wind up needing is this room size adjustment, um, and that's what we wind up using to calculate our x and y for virtually all of the movement in this game. Is that's how it winds up occurring, almost all movement. If this game was not so was not so difficult with those separate sized rooms, actually we would wind up using this instead. And in fact, this is what we use when an estimated. So when we're moving from one room to another, where where you can't see the room you've moved onto on that tech map, where you can't see the room you're moving into, actually that's the code that's needed. This code is there's nothing. The code behind this Um, it's basically what all the sorting, the collecting. I believe it's everything in this, and if I remember right, nope, it's I believe it's everything in the room data. Yep, the room data, and then the direction um, uh, folders here. And there's quite a bit of code involved with it. I wanted to point out that just to be able to give that real example of how that equation winds up occurring. And then you can see here, like there's that the player climbs, and we know that we're doing movement that's both horizontal and vertical, as we had seen in that Coliseum, where we went up steps. And then we can see here you get that steps go up, and then we're calculating the z position accordingly and adjusting it. And then when everything winds up being said and done, is we have like basically the final movement portion. Here is we wound up if the room was if we wound up moving into a room that we've already moved in, we wind up getting the ID for that room, and then we connect it to the room that we are previously in. Again, global variables in Lua, they honestly make you kind of lazy. So all of that connection data, it's being collected from global variables. And then if it's not, if it's a brand new room, actually we're going through and we're using the add room, which basically goes through and makes the room according to the X, Y, Z coordinates. Um, these room dot chords, and then so there's the XYZ there that we had collected above. And I actually, again, those global variables, they they make it so you do not feel like passing arguments to functions. So I'm just putting it in a global variable, and then that's actually winds up being used here. And in fact, actually, even this connect the rooms is called should wind up being near the end of, because first we create that room and then we connect them. That's there's there's a whole bunch more um, involved with with the mapping system, um, and just like like there's something that occurs for if movement winds up failing, but I won't wind up covering all of that here. The video is already too long as it is, and that would make it even more terribly long. I just wanted to simply use this example as not only overcoming a very significant technical challenge, in that I created a track where the character is moving using no coordinates. That's the big thing. I am not provided X, I'm not provided Y, I'm not provided Z. I calculate those based off of the character's movement themselves. Um, it was a lot of fun for me. I honestly really enjoyed it. But the other thing that I wanted to reiterate, even though I know I mentioned it before, was the fact that I did not want to use math when I went through and do this. And of course, there's math involved, um, there, because you can't do it with no math. But the large vast majority of that math has been removed with collecting data, putting it into an array, and then basically referring back to the specific element within an array or that matrix. Because really, that's what I'm doing here is making a matrix, and I'm referring back to a specific element within that matrix. Normally, that's something you would wind up only seeing, or more commonly, you would wind up seeing with either AI or 3D um, 3D movement tracking that you would typically see with VR items like that, because those are more of something that you would need to be concerned about processing time. I just wanted to have a technical challenge, kind of move it in to this two-dimensional equations, and it just wound up being a very fun technical challenge, and I really enjoyed this portion of this project. But again, my name is David. If you would like to get a hold of me, I'm going to provide a link to Parthia's Discord server. I'm not very active on it, but eventually you'll wind up hearing back to any contacts that you give to me. My handle on Discord is Dave with a nice hat. So thank you again. Have a good day.